So I would say not to freak you out if I meant that, but I'd prefer if you get freaked out actually. So apparently in Angel, when you don't submit an assignment or something like that, it doesn't actually put in a 0 for your grade by default. So if you log into Angel and you see that you're doing pretty well in the class, and you're dumb enough to think that, oh, I didn't turn in half the assignments, why am I doing okay in the class? Must just be Lippmann curving the heck out of it. That's not the case. I'll go through and put in the 0s where you didn't submit an assignment, because what I do is I grade the assignments that were submitted. So those people get points. For the rest of you, when it's calculating your grade in Angel, it just assumes that you didn't have to do that assignment. Doesn't give you a 0 in it until I go to the end. When I calculate your final grade and you see all these columns in there that don't have anything, I just fill them in with 0s then. So I think there might be a thing I can do in the future that sets a default grade of a 0 and then you earn points from there. But for some people in all my classes, if you know that you haven't turned in a bunch of assignments and you think that you're doing well because the number in there says that you have a B or something, you're probably not doing very well if you haven't turned in like half of your assignments. I'm looking right at Nick, actually. How many of you not turned in? Yeah.
Oh, I have the two papers at the end that I got to do.
What about before that?
I have everything else.
So, anyways, I find that funny. So if some of you are freaking out now, good. All right. Most of you are not in that case.
You said partial credit for turning in those assignments, right?
It depends how late they are. You had the papers from when you were sick?
Yeah.
I'll take those because I know you were really sick. So when you submit them, tell me. For the rest of you, when you turn in something late, if it's just a little late, I usually give you a maximum score of a 70. If it's very late, I usually put in very late with a smiley face and give you a 0. And for those of you who've turned in something very late, you can attest to the smiley face. I put the smiley face on there. If Angel let me draw, I would draw. I like drawing. Okay, so we're going to talk a little bit more about the Bitcoin Core source code today and how that works. And in order to kind of dive into that, we need to talk about one of the natures of the Bitcoin protocol. That is, it is a peer-to-peer network. So this is peer-to-peer network. What does it mean for a network to be peer-to-peer? As opposed to a client server. So, not client server. So we're used to dealing with client server where we go to Amazon.com, put in our username and password, and we're the client, they're the server, and we just keep exchanging information back and forth. Go ahead.
It's sent to all the people that have the blockchain. So instead of it being up to one main thing in the cloud or whatever, like you're talking about, it goes to the server. This goes to everyone in the blockchain. It syncs by that.
Okay, so forget about Bitcoin for a second. So don't worry about the blockchain aspect of this. Just peer-to-peer in general is a network of a whole bunch of people that are linked to each other, not to some central node. That makes sense? So if we think about this from the world of Bitcoin, each of us is a node in this peer-to-peer network. Okay, and let's just assume we're all miners, especially Ape and the forking issue.
I'm not really positive how you got from mining. But I like it.
All right, so in any case, Each of us are on the Bitcoin network in some way trying to earn Bitcoin. So we're doing the whole mining thing. None of us is the recipient of a transaction as an individual. Is that correct? I mean, so we all want to play the Bitcoin game. But we're all over the world. So right now we're in a single classroom, but just imagine that we're actually looking at ourselves from a 10-mile above view, and we just see ourselves as a bunch of dots on a map. Okay, so we're all over the world. We don't necessarily know about each other yet. Now, when I start mining, when I get onto the network, I want to join the network for whatever reason, and we'll talk about some of the API functions today that are things that you can do on this network. When I jump onto this network, and I need to somehow link to this peer, and somehow link to that peer, how do I do that? How do I find these guys? Let's say we were all strangers. Okay, so we're all strangers, yet we all have a common goal of working together on a project. Usually when you're doing a project-based thing, you know about who your partners are, right? In this case, you don't. You don't know who your partners are. So you guys are spread all across the world, yet we each know that there are a bunch of other people we have to work together with to solve a problem. How are we going to find those people? Okay. There has to be a central authority, right? Has to be some sort of central authority. And what's the central authority going to be able to, what should it tell me? In real life, if I go to some central authority and I say, who am I supposed to be working with on this? And they come back and say, oh, you're supposed to be working with Amish. What information do I need to know in order to connect with Amish? Phone number, email address, some kind of destination address that I can call or email or text, whatever, right? So I need to know that. So in the networking world, we need to know an IP address. We have to know a unique IP address that a specific machine has in the world of the peer-to-peer network. Okay, who's this central authority? Remember, we go way back to the beginning of Bitcoin, and we talk about that Bitcoin is decentralized. Good. Aliens. I know it was a guess, but it's actually right. Okay, so the aliens actually created the about 20 minutes into the alien Bitcoin protocol. I keep like rubbing the back of my neck, some kind of implant. Isn't that where they usually put it in the back of the neck? Don't they? Isn't that where all the no, the probes are someplace else, but alien abductions, don't they usually, isn't the thing they do some sort of like little piece of metal implant in the back of your neck? Haven't you ever watched XFiles? Must be true. Plus, they got the alien bees. You see, how many of you never saw XFiles? A great flick.
All the show's better than the movie.
Well, the movie's based on the show, but it's a movie, not a 600 episode, decade-long television series. You go a little deeper with that storyline. How did I get? Aliens. That's right. That's how we got there. Okay, so we need to have a central authority for detecting our peers, but Bitcoin is supposed to be decentralized. As Bitcoin freak shows, we don't want to trust anybody, right? That's the whole point of Bitcoin. Decentralized, government's bad, blah, blah is bad, whatever. If it's not decentralized, it's bad. But now you just told me that, okay, we have the, well, first of all, before we even go to that part, why is it a peer-to-peer network rather than a client-server network? Kind of sort of already answered it. It's decentralized, okay? But you just told me that even with the peer-to-peer network, we have some aspect of it that's centralized. Because I don't know about my peers. I got to go find these guys somehow, right? Okay, so at the very least, we're going to say a peer-to-peer network is more decentralized than a client-server network. Client-server network, by by definition, is centralized. We have a central server that all the clients connect to. That's very centralized. Okay? So we can agree that we're going to need some sort of central authority for determining who our peers are, finding them. I need to be able to find Amish. And know that he's one of the peers on this peer-to-peer network that I need to link up with to create this web of awesomeness for mining Bitcoins. Who is that central authority? You put yourself in the shoes of, and it's a pattern we keep seeing over and over again. Go ahead.
Everyone. Decentralized essential authority.
It's decentralized essential authority. I'm just going to ask everybody. Somebody will know the answer. But they're going to encrypt the answer and let me know so I don't know where it came from.
We already have a blockchain, which is the same thing, but which is everyone has the same blockchain, but it's spread across a bunch of different people. So you could have a list of IP addresses saying these are the people in the network, and then just distribute that out.
But that becomes a chicken or the egg problem, because what we're talking about here is how is the blockchain maintained? The blockchain is maintained by a peer-to-peer network, and how does the peer-to-peer network come together? Well, you need to have a centralized authority. So we can't have the blockchain without a centralized authority, so we can't use the fact that the blockchain exists to tell us that a centralized authority is okay.
Well, once the people in the peer-to-peer network know about each other, do they still need the central authority?
No, they do not. Once they know about each other and they've established a connection, as long as they keep holding hands, they don't need to deal with the central authority. Okay, because they have all their peers, right? They're a one link in a web. I say a chain, but it's really a web.
Could you have like a central authority like seed, and then once you have a network going, just ask the central authority. And then anyone that wants to join just kind of needs to ask one of the people that already knows about the network.
How do you find that person? Doesn't that person then become a new central authority?
I guess. But
so what he's saying is, let's say this half of the room. We've established our peer-to-peer network. Okay, we trusted somebody at the beginning against our better judgment. We trusted somebody, and we formed this peer-to-peer network. All right. Now Steve wants to get in on this. It's like, heard about this Bitcoin, blah, blah, blah. I want to start mining this, so I'd like to become one of the nodes, one of the peers in the peer-to-peer network. Huh?
One of us.
One of us. I want to become one of them. We start off with a probe. We're pretty low tech, so it's actually about this size. And we put it underneath your toenails. Not pleasant.
Like bamboo.
It's not pleasant. Okay, so in any case, you want to join. So what Amish is suggesting is that one of them becomes the new central authority. You might not call yourself a central authority, but in order for it to work that way, he has to know about one of you. So in essence, that person is now a central authority, right? Well, why should he trust you? Maybe he's more trustworthy than you are. Maybe you're going to give him the wrong address and act as a middleman, and any mining that he does, you're going to flow through you, and you're going to steal all the coins he might mine.
It's against his Amish ways.
So would mining Bitcoin.
Yeah.
So not if you use 4,000 hamsters.
He does it. Write it out by hand.
There's a thing out there somewhere of somebody who solved a single block by hand. And I think it took him 9.5 weeks or something like that. And this was like on a really early version of difficulty for the blockchain.
I feel like now you would die before
Yeah.
you could solve it.
Or at least carpal tunnel. You just give up.
either die or get really lucky, guys.
Yeah. That'd be funny. The person just gets it the very first time.
Oh, hey. It's like, oh, I won.
That's right. All right, so even in your example, we need to have that central authority. So according to you, and I think you're right, we have to have a central authority. But we need to be able to trust the central authority. And by definition, people who are fans of a decentralized cryptocurrency don't trust anybody. Right? So who what would be what would be some of the characteristics, instead of asking specifically what that central authority is, which I'm telling you there is one. What would be some of the characteristics of a central authority that the peers on the peer-to-peer network for Bitcoin might be okay with?
It's got to be as decentralized as possible.
Okay.
So having as many people involved in it can verify whether the transactions are true or not. So that becomes more decentralized if people have control whether or not a transaction is legal, instead of just one entity being in control of that.
Okay, well the peer-to-peer network, once it's established, that accomplishes that. I mean, the peer-to-peer network, once it's established and all of us are linked together, we've somehow worked through a central authority, we've linked together, we're all working towards the same goal, and that is, well, we have the goal of earning Bitcoin, right? But we're doing that by working as a team trying to, decode blocks. But each of us are trying to decode blocks. We're all trying to decode the same blocks at the same time. And then when one of us wins, it's kind of like a room of people playing bingo, right? Somebody yells bingo, and then everybody else checks to make sure they didn't cheat, right? In fact, actually, that's kind of exactly how Bitcoin works. Never thought about the bingo connection. It really is like a room of people playing bingo. You're just not going to trust the old lady you call bingo, right? I mean, you're pretty sure you saw her stumbling into walls on the way in. She might have just been sitting there, just plopping down dots. You get the professional bingo players. Have you seen those? My grandparents are in like not an assisted living place, but like a retirement community with a bunch of really old people. And it's the same retirement community that if you watch the show Seinfeld, his parents were in. It's literally the same building. They're in phase 4. So my grandpa knew actual Jerry Seinfeld's father before Jerry moved him out to Boca, to a rich place. But it was an interesting thing. But in any case, they have 2 or 3 nights a week at the bingo. I tell you what, some of these ladies, they're playing 9, 10, 11 cards at once. They have specialty bingo pens, like the things to put the dots on. They come geared. They're intense. And plus, a lot of these are like old New York Jews. They get mean. Seriously. All right, so you said you want them to be decentralized. What does that mean? What does that mean? So again, we're talking about the characteristics. So don't think Bitcoin for a second. Just think that you're not a trusting person. Okay? And all of you in here, we're not going to be trusting people. Yet we want to partake in something. We want to all participate in this network. Who are you going to trust? What are the characteristics of that person that you're going to trust? Just generally speaking. Okay, tell me about those credentials.
How long they've been in the Bitcoin game, maybe.
Well, we're not even talking about Bitcoin. Yeah.
Okay, so how long they've been in something, what type of respect they have in that field, that sort of thing.
Okay, so if we change the picture a little bit here and we say, okay, let's say you're going to borrow money to buy a car. Okay, are you going to go to Joe the money shark? Or are you going to go to Wells Fargo Bank? Well, it depends if Wells Fargo will give you money or not. But you're probably going to start with the most trustworthy source you can go to and then work your way down until you find somebody who will, based on your credit score, will give you money. Right? Joe the loan shark. Did I ever tell you the story why I only have 2 toes in my right foot? The question is how did I come up with that quickly? That's mental illness.
Or he knows Joe.
Or I really only have 2 toes in my right foot. Okay, so you're going to go to somebody who's trusted. Okay, and we have our standards for who we're going to trust. Like, we would trust Wells Fargo. You might not like the banking industry or whatever, but we've heard of them. We've seen their commercials. They seem to have a lot of buildings all over the place, stuff like that. So chances are they're not a shady operation. Or if they are, they're screwing over people that are a lot richer than us. right? They're doing something with hedge funds or something like that. Not trying to skim anything off the top of your $8,000 car loan. Yeah, that's not where they're spending their time. Okay, so we trust them. Why? So taking that problem a little step deeper, why is it that we trusted Wells Fargo? They earned a reputation, right? Because they've lent money to people before us. And you haven't heard that much news about people getting screwed over by them. You might hear people saying they got screwed over, but chances are they just stopped paying their mortgage and are wondering why Wells Fargo is complaining. I don't know. My bank won't stop bothering me. Well, when was the last time you paid your mortgage? 3.5 years ago, but I just don't got the scratch. All right. So that's when you go to Joe the loan shark. He starts, renting to own some of your body parts. You can't pay for it. You can't pay for entertainment like this.
Oh my God.
Would you agree that if you are going to borrow money from somebody so that you can do something, you want them to not have a interest in competing with you in what you're doing? So for instance, if you go to Wells Fargo to borrow money for a car, you don't want Wells Fargo to also be in the market for that same car, right? Why would you borrow money from somebody who doesn't really want you to get it because they want to get it? Make sense? The bank example is a little bit weak for that, but you kind of get what I'm getting at. Okay? You don't borrow money. You don't work with somebody who's your competition, hoping that you get ahead. If you're working with your competition, at the best, you're both going to get ahead. Right? Okay? So if we could identify a source, the central authority, that doesn't have an interest in what we're doing, but still is trustworthy, would that be okay? As people who are not trusting, if we could find somebody that is trustworthy but not in competition with us, would that be okay? Could we all agree to trust this person knowing that they have no interest whatsoever in competing with us? They're the unbiased third party, right? Whenever you're gambling on something, well, you give all the cash to one dude in the middle who's not gambling, right? Doesn't matter what happens, he doesn't win. He's just holding everybody's cash and make sure, he's the one who's in charge of giving it out to the winners and, watching the losers cry. But he doesn't have a vested interest in the gambling, in the bet. So we'd be okay with that. Can you think of anything that exists today that we could use to tell us who the peers are that doesn't have a vested interest in Bitcoin? Give you a hint. It's going to be an existing network, something that existed well before Bitcoin ever existed, and it's used for something else. Go ahead. Well, potentially, it's not GitHub, but I suppose you might be able to come up with a reason to trust GitHub. Let's just say no. But I would say, generally speaking, GitHub's fairly trustworthy. But everything that GitHub does, they're doing in their own interest, to some extent. Right? They have their licenses where, do you want to use it for free? No problem, but you have to support the open source community and make it public. If you want to have it private and you want us to store your crap, no problem, give us money. So they're still doing it in their own interest. So we probably wouldn't be likely to trust somebody who can make money off of us. Who's going to do something for free? Maybe you've heard of DNS. DNS is Domain Name Service. What is that? Most of us have probably heard of DNS, right? At some point, we saw it in one of the settings in our internet networking thingy. We maybe have even heard of domain name service before. Anybody know what this guy actually does?
Does it assign IPs or?
That's DHCP. You're thinking of that guy. Dynamic Host Control Protocol. He's the guy that assigns IP addresses. But you're not horribly far off. You're in the right realm of, you're in the corner of the world dealing with the right stuff.
Server gives name, the IP address.
Yep, it's a mapping. Okay, it maps between a domain name, google.com, and its IP address. That's what the DNS servers are for. And notice I said servers. DNS is an open protocol. So when you, so DNS in and of itself, the DNS service is a peer-to-peer network, so to speak. That is, you have, I want to say there's 5 top-tier DNS servers that are duplicates of each other. They all mirror each other and they're in different parts of the world. That information might be a little dated. Last time I really looked into this, I think it was 5. Doesn't matter, it still works this way. So there's some trusted ones, but they're still duplicates. There's not just one central guy. These guys mirror each other. Then below that, we have some regional ones. Below that, you have some less regional ones, and so on and so forth. So for instance, if you're here on campus and you're down the lab and you type in www.google.com and you press enter, do you think a lot of people have gone to google.com here on campus? Very first thing you're going to do is you're going to go to campus's DNS server. If I go to settings here and go to network, yeah, so here's your DHCP thing. Oh, DNS. Oh, I actually expected it all to be under TCP/IP. Okay, so here, these are our DNS servers, but notice, and for those of you, you can see I'm on Res Hall, so it's, if you're jealous and you know what that used to be, haha. Okay, so notice that here on campus, I was handed out an IP address 172.31.232.174. That is a routable IP address. That is, it's not one of those fake IP addresses that are given to you by like a Linksys router, the 10.0.0. whatever, or the 192.168, you know, those numbers. So this is a real IP address. Concordia at some point when they registered, they requested a block of IP addresses based on their needs for the number of computers they had to uniquely identify, and they were given this block. Okay, here's the IP address of our edge router here on campus. So if you want to do a DDoS attack on the router, you can do that directly, you know, an attack from the inside.
Me too.
It wasn't hard to find, was it? So in any case, so this is the IP address that this machine was given by the DHCP server. Notice that the DNS servers that I search are very similar looking numbers, right? These are other machines here on campus. So here on campus, we have our own DNS servers. So over time, we have our DNS server here on campus has collected a large number of domain names and the IP address mappings for machines based on what has happened here on campus. So the very first time somebody searched for google.com or typed in google.com and our DNS server had never heard of it, it passed the buck up to the previous guy, you know, next DNS server in the chain. You know, the guy he reports to. If he didn't know it, he passed it up until we finally got to the very top level. And that's where DNS is originally registered. So when you register a domain name, it registers with the top tier and then it filters down through requests. Okay, so when we type in google.com, it's going to ask Concordia's DNS servers first, have you heard of this guy? If yes, give me his IP address. If no, ask your boss. Ask your boss. Ask your boss. Okay, so DNS servers in and of themselves are decentralized. Okay?
Does the Concordia DNS server pull every domain that's been requested, or
It really depends on how the DNS server is configured. Some of them hold domains for a period of time. There's like a timeout. Maybe it holds it for 2 weeks, something like that. That's especially important when you run into situations where domains change IP addresses, stuff like that. Sometimes it's even less often than that. Sometimes you have long-term ones. A lot of times what they'll do, and this is where you get a delay in the DNS, is it'll have an IP that it thinks it can feed you. It'll check it before it feeds it to you. So it pings that IP and makes sure it's alive on the port you're trying to request it on. But in any case, DNS is a propagation based technology. So if you've ever done anything with domain names, and we just ran into this yesterday. You had me move that domain name from one DNS to another. So he has a website he's working on, and I had it hosted in one place, and he wanted it to be pointed to a different web address. Well, so making the change didn't take me very long, but we had to wait. It actually happened pretty quick. It took about 5 minutes, but it took about 5 minutes for it to propagate over the internet that new information. That domain name no longer points here, it now points here. That makes sense? So whenever there's changes made, it has to propagate down and update the child DNS servers. Okay, so DNS already is a decentralized service. We have a whole bunch of DNS servers, and anybody who wants to have a DNS server can. Anybody. You don't have to be a member of the special club. You can always create a new child DNS server and report to whoever your DNS server is above you. Yeah.
So, if a couple bombs got onto the 5 main ones, that would be bad. You couldn't.
You would lose your top tier.
You couldn't register any new ones. Is that correct?
Well, not while they were still destroyed. But the hope is that all the data that's on the top tier ones could be reassembled by all the sub tiers, the tiers below that. So the hope is that there's nothing that's completely unique to the top tier ones that couldn't be found from one of the other ones.
just because the top tier ones are destroyed doesn't mean that all the rest of them forget what they know.
Correct. That's it. Now, having said that, there's probably some sort of timing issue where maybe DNS names that are were registered in the last 15 seconds or something like that are gone. They hadn't propagated or something along those lines. But really, what you're talking about is an interesting problem. I mean, it's scary, but this is why those top tier ones are not sitting right next to each other. It's not like we have the 5 servers sitting in Atlanta, just in the basement of some dude's shack. You have them regionally located. There's one in Europe, one in Russia, whatever. They're all over the place. That's actually a good question. I'm sure somebody funded them. I don't know if they have a direct ownership. They're going to fall under the purview of one of the, probably IEEE for standards. I don't know the answer to that. I don't know who actually owns that. It's a good question. Yeah, I mean, it's that kind of idea. Like, who owns the internet? It's the ownership is even decentralized, I guess, because everybody can play. Everybody can add stuff to the DNS. Doesn't cost you anything. In fact, we've seen that in the Bitcoin world. Bitcoin has created this idea of the .io domain, right? So you can create the whatever.io, and that's your new domain name. Well, if you go to GoDaddy, you can't buy a .io domain name. They don't recognize that as one of the tiers, one of the known domain names. You go through the people who came up with Namecoin. The Namecoin people made that alt currency specifically for creating .io domain names, and what they've done is they've created their own top-tier DNS server that updates those other DNS servers with .io domains. So they've decided to make their own little authority. You probably wouldn't have to blow up as many places to get rid of all the .ios. is the is the
That's really well.
is the I just really need to know how many people I need to attack. It's kind of what I'm getting at here. But in any case, that's kind of an interesting thing, you ask is what if, somebody simultaneously targeted a whole bunch of very important locations like that. They took down all 5 top-tier DNS servers. At the very least, that would be disruptive, right? And probably you'd lose some data. Well, what if you went down one more level? And let's say there's 30 of those. You could, just like taking out the power grid. What if the power went out in the United States? That would be pretty debilitating, right? So it's kind of, it's an interesting problem. We probably would put power ahead of the internet, but, well, obviously the internet's kind of based on power, but you might say that most of us would be every bit as debilitated without the internet at some level, as if we didn't have power. I don't know, it might be an interesting thing.
To register a name on the DNS server doesn't cost anything. How do you do that? You get a website from GoDaddy or whatever.
Mm-hmm.
How do you go to the top level DNS?
It does cost you something when you go through something like GoDaddy. You can set up your own peer on the DNS network, and as long as you have a unique domain, you claim ownership to the domain. So when you register a domain, the domain gets registered under your name, and you can lock that domain.
How do you do that?
Well, the way you see it is through GoDaddy. If you go to GoDaddy, you can buy a domain name, and they register it for you with IEEE so that you get your standard and you can lock that domain. So nobody else could then create a domain. Nobody else could say, I want the awesomefat.com domain. So I'm just going to take it and register it. Okay, they can't do that because the domain at the top level where it's been added to the domain thing, it's locked. So you can't, let's call it password protected. So if you try to go in and say, that's not the real guy. I'm the real guy, even though you're not the real guy. Okay, I'm the real guy. Now you're not going to be able to overwrite that record because that domain name can only be modified by somebody who has access to it. You have to have the credentials to access that domain name. So for most people, what you do is you go on to something like GoDaddy.com, you pay your $8 per year for your domain name. GoDaddy.com automatically registers it with the domain name service, the top tier ones, and it costs you $8 per year. That's what most people do. If you wanted to go through the headache of setting up your own DNS peer, where you're on the DNS network, and you could identify a domain name that doesn't already exist, that isn't already taken, you could actually do the registration yourself, okay? Which I think does cost something, but it'll be, GoDaddy is selling it to you retail, they're paying wholesale for it. So there's a cost that's less than the $8 per year they have to pay. I'm pretty sure it costs something. So you would pay that, you'd register that domain name, now you own that domain name, it's yours. Okay, you legally own that domain name. Then you'd use your DNS peer to put it up into the cloud, into the top tier DNS servers and let it propagate down. Awful lot of work to save $8 a year. So it's kind of the punchline. Okay, so anyways, by default, DNS is a distributed, decentralized network. It's exactly what we're looking for. Now, DNS's job is to hand out unique IP addresses based on the domain name you give it. That's its job. It does a mapping. Okay? That has nothing to do with Bitcoin, correct? Not directly. But if you are a Bitcoin miner, we're all these peers on the Bitcoin network, how are we connected to each other? Could we have the Bitcoin network without the internet? Practically, no. Realistically, I guess you could run a whole bunch of wires between all the peers and just hard code it, right? But practically, no. And when you go out, you could buy a Bitcoin miner, you could hook it up, and now, when you hook it up, it connects into the internet. You give it the IP address or the domain name of the pool you're going to connect to. I use ghash, so it's ghash.io port 3333. You give it the username and password to register you. Now it's mining for that pool. So they put you onto the peer-to-peer network. Okay, so you're actually connecting into a subnetwork, which is Ghash, and then Ghash is a member of the peer-to-peer network. That make sense? So the idea here is that DNS has nothing to do with Bitcoin, but it has everything to do with the same kind of technology that those Bitcoin peers rely on. They rely on the internet, unique IP addresses. When Amish has his mining machine set up, he's going to have a real IP address somehow. Okay, well, even if it's behind a router or something like that, he's going to be connected up to somewhere. So by opening that door, now there's a connection we can get to. So when he's registered with the network, he therefore could be linked to. We just have to find them. Well, how do we find them? Part of the Bitcoin core software is hard-coded DNS servers. Okay? So there are known DNS servers, just like we just looked at on here, and we saw there's 2 DNS servers for Concordia. There's a list of trusted DNS servers as part of the Bitcoin protocol. And these guys' job, and it is a DNS server, it's not like DNS. It's actually part of the DNS network. Okay? So these guys' job is to hand out the IP address of another node, a peer, on the Bitcoin network, Bitcoin's peer-to-peer network. So when you first bring your machine online, if you're going to join that peer-to-peer network directly and not go through a pool, you would hit one of these DNS servers. It would give you the IP address of one of the links in the chain, maybe Amish, and then you would connect directly to that. Now you're plugged into the peer-to-peer network, okay? Because he knows about the person he's connected to, who knows about the person he's connected to, who knows about the person he's connected to. That make sense? And most of these nodes are connected to multiple people, so it's a big web. So in terms of data structures, this is called a graph. All right, so we'll stop there on Friday. We'll start off by talking about the final a bit, and then I want to try to finish this conversation. We're going to finish off looking at some of the developer documentation stuff for Bitcoin, specifically some of the core API stuff, remote procedure calls they have. All right, I'll see everybody then.